The moment of force. Moment of force is the turning effect that is produced when a force is acting on an object at a fixed point, aka the fulcrum. The moment of force dalam bahasa Melayu adalah momen daya. Daya yang dikenakan pada sesuatu objek boleh memutarkan objek itu pada satu titik yang tetap, iaitu fulcrum. Kesan putaran ni kita panggil momen daya. The effect of rotation can be seen when we open the door or when we use the spanner to tighten a nut. The moment of force depends on the force applied and the perpendicular distance from the fulcrum to the force. Momen daya bergantung kepada daya yang dikenakan dan juga jarak tegak daripada fulcrum ke daya. Hence, the moment of force can be calculated using the formula M equals to F times D. M represents the moment of force in Newton meter, F represents force, and D represents the perpendicular distance from the fulcrum to force. Formula momen daya adalah daya darab jarak tegak daripada fulcrum ke daya. Jadi, unit bagi momen daya adalah Newton meter. Unit for moment of force is Newton meter. So you can see here, the moment of force is the turning effect that is produced when a force is acting on an object at a fixed point, which is the pivot or the fulcrum. So this is the perpendicular distance measured in meter, and force is measured in Newton. The moment of force has two directions. They are clockwise or anti-clockwise. Momen daya ada dua arah. Sama ada ikut arah jam ataupun lawan arah jam. For example, here we have a spanner used to tighten a nut. So the moment of force is equal to the force used, which is 50 Newton, times the perpendicular distance from the pivot to the force. So the distance from the pivot, aka the nut or the fulcrum, to the force is 20 centimeter. So we just calculate 50 times 0.2 meter. So you get 10 Newton meter. Remember to convert the distance from centimeter to meter. 20 centimeter equals to 0.2 meter. Example 2. The force used to open the lid of a can is 10 Newton using a spoon of length 15 cm. Calculate the moment of force. So moment of force equals to force times the perpendicular distance from the pivot to the force. So the force equals to 10 Newton and the length of the spoon is 0.15 meter. So the answer is 1.5 Newton meter. Since the moment of force depends on the force applied and the perpendicular distance from the fulcrum to the force, we can increase the moment by increasing the magnitude of the force by applying a greater force dengan mengenakan daya yang lebih besar. That is how you increase the magnitude of the force. Secondly, we can increase the moment of force if the vertical distance from the pivot to the force increases. Kita boleh meningkatkan momen daya dengan meningkatkan jarak tegak daripada pivot ke daya. So, if you have situation A and situation B, both of them uses the same amount of force, but the distance are different. A, the perpendicular distance is 0.2 meter. Meanwhile, in B, the perpendicular distance is 0.1 meter. Between these two, which one do you think will produce a greater moment of force? Exactly. Figure A will produce a greater moment of force because the perpendicular distance from the pivot to the effort is greater compared to B. We've learned levers in the previous lesson. Levers consist of effort, fulcrum, and load. In the lever, there are two forces that act on it. They are the effort, and the load. Dalam konsep tuas, ada dua daya yang bertindak balas. Yang pertama adalah beban dan yang kedua adalah daya. These forces produce opposing moments, momen yang berlawanan, which are the load and the effort. The load produces anti-clockwise moment of force, while effort produces a clockwise moment of force. In order to balance the piece of wood in a horizontal position, the clockwise moment of effort is the same as the anticlockwise moment of the load. Hence, we can use the formula here for lever calculations. Load times distance of the load to the fulcrum equals to the effort times the distance of the effort to the fulcrum. Effort here times the distance to the fulcrum over here, and load times the distance of the load to the fulcrum over here. So these moment on the left and the moment on the right are equals if they are in a balanced position. Example 1, figure 8.29, this is from the textbook, shows two children sitting on a seesaw. What is the distance of Jiayin from the fulcrum so that the seesaw is balanced? Jiayin is the girl on the left. Wei Hong is the boy on the right. You can see the weight of Jiayin is 200 Newton. Meanwhile, Wei Hong is 300 Newton. So the load times distance equals the effort times distance as well. So on the left, Jiayin is 200 Newton times the distance, which is unknown. We put it as D. Meanwhile, Wei Hong sits in a 2-meter distance from the fulcrum. So 300 Newton times 2. So 200D equals to 300 Newton times 2. D equals to 300 Newton times 2 meter divided with 200 Newton. So D, which is the distance of Jiayin to the fulcrum, is 3 meter. So in conclusion, Jiayin has to sit 3 meter away from the fulcrum so that the seesaw is balanced. So that's all for today's lesson. Your homework is to complete the Science Process Skill book in page, if I'm not mistaken, page 108. Yes, 108, this one, until 109.